All right, so we're given an n by n binary matrix grid, and they define island as a group of ones, which ones represent land, zeros represent water. The land, for it to be an island, the ones have to be connected horizontally or vertically, not diagonally. So, yeah, and then the area of an island is just the number of all the cells that are together with the value of one. And then they're looking for the maximum area of all of the islands, right? If there are islands, otherwise they want zero, right? In the case where there are no islands. Our grid is going to be at least one cell big. That's a guarantee. And for this first example, we can see the output is going to be 6 because the biggest island here, 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. That's going to be the answer. Notice how these are separate islands, right? This one is separate from this one underneath it because they're only connected diagonally, which doesn't count. They wouldn't be part of the same island. So yeah, the time and the space complexity for the way we're going to solve this, I'll do the whiteboarding in this way, just so we can get through this problem a bit faster. So we're going to have to basically look at every cell on the grid once, right? So that is going to be guaranteed m times n time complexity, right? Then on each cell, so this is like the outer loop, right? And inside of this 2D loop, right, which gives us our initial time complexity, we're going to be potentially doing a flood fill, right? So how long is our flood fill going to take? Well, in the absolute worst case, we could literally have every single cell in the grid in our recursive call stack. So that would be like m times n, right? If we, say we are have looking at a grid and then literally the whole 50 by 50 thing is ones, you would have all of those in the call stack, right? But we're not going to be doing that more than once because we'll have an extra data structure for our space complexity, which will be a grid of the same size as the input, which will just be Booleans. And then that will tell us, we'll have a mapping basically that tells us, okay, we've seen this element at this position, yes or no, right? That way we're not retracing our steps. So this will saves us time complexity, right? And it's necessary for the algorithm. Nevertheless, right? So this is our space complexity. So we're only going to be doing this part, right, inside of our outer loop if the cell is 1 and if we haven't seen it, right? So, and then this will just simplify it like m times n plus m times n. That's just 2m times n. And then obviously for big O notation, the coefficients don't matter. So that's the time. And then the space is this. And then it's kind of a similar story here, honestly, because we have that visited array, but we also have some space in the recursive call stack, right, separately. So like in the very worst case, right, that's going to be m times n in case like the whole grid is like a single island, right? So, but again, that's just addition, right? We just get a coefficient 2m times n. It's just m times n. So yeah, so that's like a little bit of a dive on the time and space. And yeah, that's like pretty much all there is to this problem. So if we can take that at, for what it is, we can code a solution, right? So the very first thing we're going to do is have our outside loop. I'm not even going to worry about the other things we need yet, right? The other state we need. We just need this loop. That's the first thing. We need to look at every cell. So let's just do a C-style loop. We will loop over the rows with I. There's as many rows as there is grid.size, and then I++. And then for each row, we want to iterate over each column, right? So we'll say another C-style loop, j equals 0, j is less than we know there's guaranteed to be at least one row. So we can take the first row and take its size. That's going to be the number of columns, right? So, okay. So at this point, we have a loop where we're going over every single position in the grid. Now, we also want to keep track of where we have already been. So at that point, we're going to need that. So we need a 2D array, just the same size as grid, but it can just be Booleans, right? We just need a mapping, yes or no, for that position. Have we seen it or not? So I'll call it seen. Let's give it some size. So when we're initializing a vector, just like a 1D vector, right, we have to give a type, or we have to give a number first for the number of elements, right? And then second, we give the type. So for this nested thing, we have to kind of do that in a nested way. So the first thing is going to be the number of rows, right? So that's going to be grid.size. And then, so that's the number of things. And then it's the type of things, right? So the type of things is going to be this like nested thingy, right? So it's a vector of Booleans. Right, it's a vector of Booleans. And then we have to initialize that, right? So that's going to be we can just take, again, we know there will be at least one row, so we can take the first row's size to get the number of columns, and then those are all going to be false at first. That's and it's not the type, it's the value, right? So this is the so not the type, right? I keep saying type. So this is like the number of elements. This is the value, right? All of those elements are going to be this vector of Booleans, which is the size of those is instead of number of rows, it'll be number of columns, and then false. And then basically all this is doing is we have a grid or a visited 2D vector, which is like the exact same size as this one. So that's all that's doing, just like in a line. And then we want to keep track of the area we've seen, right? That can just be 0 at first. And let me just put this state together. Okay, so we're only going to want to do a flood fill if the cell we're on is land. So I could just say if ij, but to make this like really explicit, we'll just say if ij is 1. So if it's land and if it's not seen, right? Those are like the two checks. Okay, if both of those pass, we can try to update the max area and then do the flood fill. So so first we'll say we can actually do this all in one line, right? We can say area is going to be equal to the max of whatever it was before, and then we're going to call this flood fill function, which we have yet to define, right? But that's going to take a couple of variables, right? So the first thing it's going to take is we know it's going to take the grid. So let me just start coding that as a private method up here. So it's going to return the area of itself and then all of its neighboring unchecked cells, right? So it'll return an integer, right? That's like the area observed so far. We'll call this flood fill. We're gonna have this grid variable, and then we also want, let's see, this vector of Booleans, right? This one's also by reference, and then we want an int I and an int j for the current position we're at, and that should be it, right? So let's seed this just while we're here. So grid scene I j, right? That will seed the flood fill, right? Knowing that we need to, given those conditions. And then the first thing we're going to do is just check, okay, if grid I j is, if it does not equal land, like if it's water, if it equals 0, we just want to return 0, right? This doesn't contribute to the area, and we don't want to do any more recursive searching, right? So if it's 0, we're going to return 0, right? And then the other condition we want to check is also if it's not and, but or if it's seen, right? So it's like either of the two. If it's not land or if we've already seen it, let's just return 0. Okay, otherwise, we want to start considering the area that's in this cell. So we'll say int area equals 1, right? We know this cell has an area of 1. And then we want to try to basically add the area from all of its neighbors, right? So, and then we already did these kind of checks up here, notice, right? So we're already checking up here if the neighbor is whether it's land or not, and then whether we've seen it or not. So we don't have to do those checks in the conditions. In our conditions, we just need to make sure we're staying in bounds, right, before we call the recursion. So those are like that's like the check we need to do before we just are able to call recursion. We have to make sure the new coordinates are in bounds, right? For that updated coordinate. So let's see what that looks like. Also, even before we do this, like we want to say seen ij is true, because at this point we have counted its area and we don't want to recount it, right? So we're just going to set this to true also. Okay, so now what we can do is if first we're going to do, okay, so let's break this up. So we're going to say go right I plus 1, right? So if I plus 1 is less than, let's see, grid dot size, then at that point we can safely do our flood fill, right? So we'll call flood fill on grid scene I plus 1 and j. Okay, and then I don't know why that spacing looks weird to me. Okay, that's correct though. So the next thing we want to do is potentially go left, right? So go left. That would be I minus 1. Okay, so, and what is this returning us, right? This is returning us everything the neighbor has seen, right? So we actually want to say area plus equals this, right? If it might be 0, but it might be more than 0. So just say area plus equals. We want to add, right? If we see new area. So again, area plus equals, and then this one will be area minus 1. And we want to check that minus 1 is greater than or equal to 0, right? When we're decrementing. So that just ensures that's in bounds when we're going left. And then we need to go up and down, right? So go up. And I think this is honestly going to be more similar to this one. So let me just copy this one, go up. That would be j plus 1, right? I minus 1. Actually, I think yeah, this would actually be up and down. You might have already caught that, but depending on, so like I think the I indexes are going to be the rows, right? So when you increment I, you're going up a row. And when you decrement I, you're going down a row, right? So to go right and left, we actually increment and decrement j. Just a small observation. The code is still correct, just those comments and the understanding was slightly off. But nevertheless, so j plus 1. Okay, and then finally, I feel like this is taking a while. It is 15 minutes, not too bad. Go left, J minus 1, J minus 1. Let's just get this thing. J minus 1, J minus 1. Okay, and then that's pretty much it. At the end of this, we return the area. And that's pretty much it for the problem. So we already went over the time and space. We need to return the max area at the very end of this outer loop thing that loops over the grid. But that's should pretty much be it. So let's see. Dev grid. And forgot that. And doesn't like this either. Max. No matching function call. Wait a second. Yeah, what the heck did we do here? This should be area. Okay. I think that's the last one. Yeah, cool. Okay, hopefully this helps. If it did, leave a like, and I'll see you guys in the next piece.